This video is going to talk about how to use the periodic table to simplify a lot of the problems that you have to do or laboratory experiments that you'll be doing eventually in your chemistry education. If you're new here, welcome. If you've been here before, welcome back. I'm excited to be making this video series about kind of getting started with concepts in chemistry. So let's get started with an introduction to using the periodic table. It's basically a roster of all the elements. It's everything in one place that you need, and it's really a one-stop shop for information based on elemental metrics that you might need in chemistry, whether it's a molar mass or it's the atomic number or the symbol. You're going to get this information from the periodic table. As you get further in your chemistry career, your electron configuration information can be easily determined from the periodic table as well, but that will be in a later video, more on that in future content. But they're basically all arranged by properties. So if elements are close together, namely if they're on top of each other, so above or below each other, they typically will share some type of property. And we'll get into that a little bit now as we start to talk about the periodic table. So columns in the periodic table are called groups, and you can find the group number at the top of each group. Rows in the table are called periods, and you can find the number of the period at the left of each of those periods. And as you get into more thorough chemistry information, more complex chemistry assignments and projects and tasks, you'll know that the periods are very important for things like electron configurations and other determinations of valence shell electron configurations and how to know where the electrons are. Or at least we can guess approximately where they could be in the shells. So more on that again in future content. So let's take a look at the periodic table. And this is just a screenshot from ptable.com. It's a free resource. It's what I use when I'm on my computer and I need to reference some elemental information. They are not affiliated with me in any way. I just really like the resource. So here it is. Here's the periodic table. Here are examples of some of those groups. So this is group 1 and 2. The transition metals here, if this is your first course in chemistry, if this is an introduction to you, first of all, welcome. I hope you have a great experience, of course, but these are kind of treated a little differently. So for all intents and purposes, group 1 is here, group 2 is here. Then we consider this group 3, 4, 5, 6, 7, and 8, right? So if you've looked at a periodic table before, or if you've had any experience with this, you'll probably know that group 8 is the noble gases. You'll probably know that group 17 is the halogens, and other elements are related, but these are the two that you usually learn about first because they're easy to remember, they're easy to find, and all of those elements in those groups behave like those above and below them. So it's easy to remember. It's a great way to start understanding how to use the periodic table. When you look at an element, you'll find these things. You'll find a symbol. So we're going to look at carbon here. You'll find a symbol, and it's just represented by a capital C. You'll find the atomic weight in mass. So it's listed as grams. So just know that it's listed as grams. And it's really listed as grams per mole, right? So 1 mole of carbon is 12.011 grams. A lot of times you'll just use 12. But it just depends on what your teacher recommends or prefers, so make sure to get direction from your instructor on that. Do not take what I say to be an end-all be-all. Please make sure you consult with your instructor as well. And you'll also get the atomic number, 6. And the atomic number is the number of protons in the nucleus. So we know that carbon has 6 protons in its nucleus. There are a few groups that are good to know as you start off your chemistry education journey. And whether this is just a class in high school that you're taking in college, or you're looking at these videos to review or maybe to learn it for the first time, these are going to be good to know all the time. So this is good for everybody. Group 1 is called the alkali metals. When they're ionized, they usually have a +1 charge. Group 2 is the alkaline earth metals. It is group 2 of the periodic table, like we said, and when they are ionized, they have a +2 charge. Group 17, as we said before, is the halogens, and group 18 is the noble gases. Remember, you can really think of these as group 7 and group 8, okay? You can really think of them that way. I've listed them as such because I want to make sure that it's consistent with that screenshot of the periodic table. So we can pick out the alkali metals, the alkaline earth metals, the halogens, and the noble gases. And so this can explain why, per se, sodium chloride and potassium chloride behave similarly. Because sodium and potassium are both alkaline metals, right? It could explain why magnesium chloride and calcium chloride are also both behave similarly, because they're alkaline earth metals, both bound to the same halogen. In its negative state would be a halide, but more on that later, of course. More organic chemistry related, but let's go on. How is this information helpful? What am I going to do with this? I'll tell you. The atomic number of each element is the number of protons, right? So you already have information right off the bat. How many protons are in the nucleus? The atomic weight is the atomic mass units of each specific element, but it's also the molar mass, grams per mole, of 1 mole of that element. And so more often than not, you're going to utilize the molar mass. That was a terrible line. Let's redo that. You're going to utilize the molar mass. You still need to understand atomic mass units, okay? And I think it's valuable just to understand the fact that they are kind of seen as the amount of atomic mass within that element, that specific element. So it's good to know, but you'll more often than not use molar mass. And then the element symbol is what chemists use to refer to the element. If we're talking about methane, we know that that's going to be CH4. Well, you need to know that C is carbon and H was a terrible arrow. H is hydrogen. And if you don't know what these symbols mean, if you don't know what elements these letters are talking about, you're going to have no idea what your formulas are indicating. You're not going to know how to balance equations. So it's really worth taking the time to just memorize the key recurring elements now, be familiar with the periodic table, know how to use it, know how you can leverage it to help you have an easier time as you get started on this chemistry education journey. So, periodic table, right? Not as bad as it seems. I hope this helps as you start off or re-enter your journey in chemistry education, or just having to do chemistry, whether it's in a research lab or a laboratory course or in a classroom setting. Best of luck. More content is coming with more in-depth information about chemistry education tools and resources that you can use to make this journey as smooth as possible. Happy learning.